Right? So there it is. That's pretty easy. All right, let's do an if and only if. So we have to prove it both ways, in both directions. So here's the question. Prove that the product PQ of two integers P and Q is odd. So the product is odd if and only if P and Q are both odd. Okay, you got that? So prove that the product P and Q of two integers P and Q, prove that the product is odd if and only if P and Q are both odd. Okay, so let's try and do that. Now it's an if and only if, so we have to do two proofs. We have to go in both directions. So and which is which? You know, which the if and the only if. Let's get the directions correct. Now remember it's a, well, I wouldn't say strict, but it's pretty strong convention to do the if part first. That's a pretty strong custom amongst pure mathematicians. So let's do that. We'll do the if case first. Right? So let's write out, what is it? Okay. So P and Q are integers, right? P and Q are integers. P and Q odd. If and only if. P and Q both odd. Okay? That's what we have to prove. So let's do the if case. Now let's see. Let's call that statement P. Mathematical statement P. And let's call the right hand side, we'll call that Q. Right? Statement Q. Now P if Q. So we're doing the if half first. That's the usual convention, the usual custom. So P is true of Q. So we can rewrite that as Q, if Q, then P. Remember from the theory of if and only if? P is true of Q. So if Q is true, then you get P, right? So that's what we have to prove. So if Q is true, we have to prove P. So if Q is true, that's this. So P and Q are both odd. We have to prove that PQ, the product, is odd. Okay. All right. So we start with Q. We start with this. So P and Q are odd. Right. So let's write P as an odd number. So we can call that like 2s plus 1. And Q we can call, say, 2t plus 1. Therefore, PQ is the product of these two. So 2s plus 1 times 2t plus 1. And that is 2s plus 2t plus 4st plus 1. Right? And that's 2 into s plus t plus 2st plus 1. Now this is even, plus 1, so the whole thing is odd. Okay? So therefore PQ is odd, and that's statement P. So that's P. Okay? So we started with Q and we deduced P. So the if we've done. Now the other way. Now the only if, the second half, only if. Now, so P only if Q. So that's, you can rewrite that as if P then Q. Why is that? The only way you can get P is by having Q, right? So if you do have P, you know you must have had Q. Right? So it's P, Q. Alright? So we start with P, which is PQ is odd. Right? And we have to deduce Q. So how to do that? Well, how about using proof by contradiction? So if we assume not Q. We're going to use proof by contradiction. Okay. So let's assume not Q. So what is not of this? So it's not the case that both P and Q are odd. That means at least one of them must be even. Okay. So let's say P is even. So that'll be of the form 2n. And Q, oh, we don't care about Q, right? All right. So PQ now takes the form of 2n Q, right? But that's even. That's even. Right? So PQ is even. That's the same as not P. Right? PQ is even, that's not P, because PQ's odd. Right? So PQ even is not P. So by assuming not Q, so if we start with not Q, we proved not P. But P is true. P is true. So that not Q is false. So not Q is true, which is the same as Q. Okay? So we've proved it by contradiction in both directions, and therefore we've done the IFF. And I will close there. My apologies for the teething problems, right? This is my very first, and not surprising, there are some problems. And a while back you saw me fluff something, because I just wrote down something wrong, and therefore the deduction went wrong. So it all proves to you, everyone makes mistakes, professors also make mistakes. So for lecture 2, which will be on entitled sets, so introducing to sets and set notation, and how to prove two sets are equal and that kind of thing. That will be lecture 2, which I will put up on YouTube within a few days after this one. So I hope you've enjoyed this first lecture, despite its many faults. I promise you I will find a more practical solution to this wiping the board problem, because it doesn't work as it is. Ciao.